So today my topic is on building with large language models, but we'll make emphasis on sorry, we'll make emphasis on pro, on producing structured and reliable outputs out of these models. So before I begin or before I continue, I want to ask how many of you are building using large language models? Okay, that's a good number. And I believe that many of us building using large language models, we may have we may have noticed that these models are efficient, they support many languages, they are easy to use and all. But sometimes these models can make mistakes. And in production, these mistakes are costly, right? So you wouldn't say because the LLM produced wrong outputs or the model gave you unexpected outputs that you gave the customers wrong outputs as well, or you authorized wrong information to the customers, right? And you wouldn't say as well that because the model produced wrong outputs, you allowed your pipeline to break, right? It's not accepted, right? So um, we need to therefore ensure that these models produce reliable outputs. And there are many ways to ensure that the model produces reliable outputs. One of them is using structured input outputs. Another method is prompt engineering, fine tuning, retrieval augmented generation. But today we're going to focus on structured input outputs. And why structured input output, you may ask? Well, think of an electric plug. You want to charge your computer, and commonly here in Nigeria, we have the three pins chargers, and you move to the US or to Europe where they mainly use the two pin sockets. You won't be able to charge your computer that way. So, uh, just the same way you can think of that example, the charger is the model's output and the socket is the your downstream application input, right? So if the downstream application input is not compatible with the model's output, your system won't work. Something will break, right? So we need to ensure that both of them are compatible. Let's try something together. Um, can anyone point out what's wrong with this picture? Or is it, or it's hard to see? Uh, how do I make it bigger? Okay. Uh, I'm not sure how to make it bigger, but oh, the color. Okay, so I'll go through it myself. Let's assume that this is the API's output, and the prompt I gave it is extract the event and duration from this sentence and return it in a JSON format. And the sentence is PyCon will be aired for over 4 days from July 10th to July 13th, right? So the model returns here's an extracted information in JSON format and produce the JSON. And within the JSON itself, it's gave the event and duration, but the duration has a nested object inside, a nested dictionary inside of it, which may not be the specification that we need for our application. So we need to ensure that we give structured input to the model, and the structured input and output will help the model understand the input as well as um, it will help the model understand the input as well as help the model return reliable output for your applications. So, how to structure inputs and outputs, right? So every model, each model family, Claude, Mistral, Llama, and all, they make use of different structures for for to give they make use of different structures. So basically, to instruct the model how to produce structured output, you will need to instruct it differently from each model family. So therefore, okay, I think this is an example of Claude Sonnet. And with Claude Sonnet, it makes use of XML to specify how to structure the data. However, with GPT, OpenAI, you're required to give like a long JSON schema, which um, is not compatible with Claude Sonnet. So you can make use of constraint generation libraries like instructor or outlines uh, to help you structure these models better. So here is an example using instructor. It's not very clear, but so what happens in this picture is um, I specified a pydantic based model, and pydantic based models are, you could think of data classes in Python. They are basically classes that hold data. So these pydantic base models contain the prompt as description and the fields that we need to extract and the description for the fields as well. So you can now pass it to the model and you would be able to pretty much get the same structure you would need with like the long XML, the long JSON schemas. It's pretty much the same thing, but downstream into a few lines of code. So what is possible with using all these constraint generation libraries? You could have nested models inside of it. Let's say you want to give it a list of customers, and within the list of customers, there are other metadata that you would want to add inside of it. You can define your metadata class, and you nest it within the customer date the customer model, and with it together, you can pass it to the model easily without writing long structure of code, right? You can also pass enums, and enums can help you with classification, can easily help you to classify data into different formats. You can also have validations, and validations are very important because many times when the model returns some output, you're not sure if the output is correct. So you may want to pass some checks to it before you send it to your downstream application, before you send it to your system. So you can have a validation block with this libraries. You can also have caching, and caching is very important. It can help you save tokens, right? Let's say you have a certain questions that customers keep on asking. You can cache this question, you can cache the responses such a way that whenever you get a response like that, instead of it going to the model again and costing money to generate, you can return it faster and cheaper. And also you can have retrying mechanisms. And retrying mechanisms are when the when you make a request to the model and it fails. That way you can retry it after a few seconds, maybe um, yeah, you can retry it after a few seconds depending on how much timeout you give to the retry mechanism. So where to go from here? You can scan this URL. You can you'll probably get a few libraries to work with this URL. I also added an article you could go through. And yeah, questions. Oh, sorry. Yep. Question. There's a question here. Okay. Yeah, maybe you could use my mic.
Awesome, thank you. I'm just curious because there are different approaches to control, like Llama CPP will let you define a grammar. You mentioned Claude Sonnet with its XML, OpenAI with its JSON schema tool calling approach. I'm just curious if you could share in your own experimentation, because I think we're all experimenting with structured LLM output and tool calling. which ones have you found to be most effective for the types of tasks that you're undertaking?
Thank you. Um, so I will be a little bit biased because I'm a contributor to instructor. I was an early contributor to instructor, so I mainly use instructor, but instructor isn't good for open source models. It's mainly configured or tailored for Claude and Llama and OpenAI, sorry, right? So you can make use of outlines. Outlines works best for open source models, and you have not used it before, so it's worth trying out. There's another question here.
Thank you very much for your talk. Two questions actually. The first one, you talked about caching, and most of the times when we build with LLM, we generate these prompts dynamically, which is it's not fixed some of the time. So how do you catch something like that for, let's say, input strings that differ by maybe a punctuation, an extra word, or stuff like that? Can you touch on how we can catch in scenarios like that?
Right. So to catch scenarios like that, you can make use of keyword search. And the keyword search may not be exactly correct, right? You could have you can make use of Elasticsearch for the keyword search, and with Elasticsearch, you're going to like pick out certain keywords from the question you're asking, and it's going to give relevant responses. And without relevant responses, you can pass it back to the model to filter out like which of these responses should I send out to the user rather than just sending the question the responses directly to the user. Yeah, you can pass it back to the model and yeah.
Okay, thank you. Second question. For output validation, most of the times, what I've done is just to instruct the prompt, return your output in JSON format. And while that works like 60 to 70% of the time, some of that time it returns a JSON, but a broken JSON, maybe a missing quote or a missing like stuff that just doesn't validate as a valid JSON. So these libraries that you mentioned, do they solve that problem? If not, do you have you found a way around something like that?
Yeah, so the reason why I mainly use these libraries is for validation, right? Um, you can use this library directly using Pydantic. You don't even need instructor or outlines. You can define your Pydantic model, and you just once you've initialized your Pydantic model, you can put dot model underscore schema, and you call the two brackets, and it will give you the OpenAI structure to pass to the model. So if you want to validate the output, you can have a function, a method within the class, and you can pass the outputs that the model will generate inside and do your validation uh, scripts inside of the method. Does that answer your question?
Yeah, it does, but partially. What happens in a case when the output does not validate? Do you recall the LLM or how
Yeah,
is that
you
typically?
can pass the error back to the model. You can always pass the error back to the model. Yeah,
Thank you. That answers it.
yeah. I think there's no other question here. Okay.
Question. Um, Good morning. Thank you for a very wonderful presentation. My question is pretty much simple. I just want to know um, how many, should I say, models, LLM models does this instructor support? Like how many is there like just basically like how many does it support? Even the is it just the normal popular ones that we are familiar with, Anthropic, Cloud Minstrel, and the rest? Or are there some other like those ones you find on Hugging Face leaderboards and stuff like that? Does it support a large range? Yeah, good.
Right. So instructor mainly supports OpenAI GPTs and Claude, Anthropic's Claude, but outlines actually works on Olama, and Olama is like the local model instance, something like that. So you could make use of outlines to um, yeah, you can make use of outlines to get the same, to force the model to produce structured outputs.
Yeah, I was just on that question about caching. I was just curious if you've tried an approach of, in effect, having one LLM rewrite the user's question and even including few shot examples of the frequently asked questions. So, say, here's a user question. Please rewrite it in a form that, like, if you're using RAG, that is that's probably going to get a good answer from RAG. Here are some examples of common user queries, and therefore someone then comes with a question that is almost like a common user query. The LLM could rewrite it. Of course, it's not 100%, but it could rewrite it to one of the few shot examples. So I'm curious if you've ever tried that.
So is it more of like rephrasing the question to look somehow like previously asked questions, right? I haven't tried that personally, but I think that's a good thing to try out. Yeah.
Any more questions? Okay. So thank you.
Thank you very much.
Can we give him? Yeah. Thank you.